So continuous beams, okay, continuous beams, okay. Yes. So continuous beam has, if you see it is, see how many indeterminacy. So exclude horizontal loading. It's a 2, it's a 2 1 1 4 minus 2 2. It's okay. 2 2 4 4 6 6 6 minus 2 4. So 4 indeterminacy. If you take like this, if you take like this, so 2 2 1 5 minus 2, it's a 3. So we exclude horizontal loading. Horizontal loading, exclude horizontal loading. So see, it is the indeterminacy is 3 4 more. So if the indeterminacy is more than 2, how can we solve the problems? These are all force method. How can we solve? We have only 3 equations, fx equal 0, fy equal 0, fz. So moment is 0 everywhere. If you exclude a horizontal loading, fy is equal 0, m is equal 0 at everywhere. Only the available equations are 2, but the indeterminacy is more than 2. So more than 2 means, if it's 3, it's a proper cantilever. We solved it. The indeterminacy is 4 like this extra. That means indeterminacy is 2. If indeterminacy is 1, it's a proper cantilever. We solved it. If indeterminacy is 2, that fixed beams, we solved it. So indeterminacy is more than 2. Those are the continuous beams. How can we solve those? How can we solve? So say it is, these are all force methods. Force methods, okay, not a displacement methods. Displacement methods we discussed in later. Slope deflection, moment distribution, Gane's method, those are all displacement methods. Later we will discuss. Before proceeding to the force method, that is called Clapeyron theorem, I will show one small problem, because to identify so free body diagrams, so it will be important. So I will solve one proper cantilever once again. Okay, once again I will solve one proper cantilever, because to show the free body diagrams, how we free body diagrams will draw. Okay, I will took, okay, example. This is all, you know it. If it is small, it is a simply supported beam. It's loading W by M. If another support is there in between, it is L by 2, it is L by 2. How can you solve it? How we will solve it? So just see, it is just see one indeterminacy, just one indeterminacy, we already solved. So how we will solve? Choose any method. So I will choose like, see, it is, these are not a continuous beam. It is also a continuous beam. If you see, it is continuous beam, but it has indeterminacy of only 1. If only 1, you can choose another methods also. More than 2, we will use that method. I will explain later. But this is only one determinacy. If you find out this only one reaction, remaining reactions you can easily find out with respect to Fy equal 0, M equal 0. Then based on that you can easily find out. But if you see, this has 3 reactions. 3 reactions are there. We have only 2 equations, one indeterminacy. How can we solve it? We already solved in a proper cantilever. Same method. See, it is, if it is a loading, so how will deform? It will deform like this, na? So this is the value. How much it is value? What is that value? 5 WL power 4 by 384 EI. You know it. So I will take it. So same thing. I will use one reaction R. That cause this reaction is R. If it is using R, how will deform? It will deform like this now. So what is the deformation here? What is the deformation is? RL cube by 48A. You know it. You know it now. So if the simply supported beam central point load acting RL cube by 48A. You know it now. So based on that, at the location of this is A, this is B, C. At the C has a support. C is a support. If C is a support, deflection at C is 0. Are understood? Deflection at C is 0 because it is a support. I feel it is like some reaction is applied at C location. So based on that, the deflection at C is 0. Are understood? Deflection at C is 0. So see it is, if you combine those two, and that deflection is deflection at C is 0. Deflection at C is 0. That will be end of the examination, end of the problem. Understood? We solve it. We solve the problem cantilever same like this now. So I will use that method because it is not related to any force method. I just saying this problem to show in the free body diagrams. Okay. So based on that, these two assumptions, C has deflection 0. Okay. C deflection is 0. So that means 5WL44 by 384 EA is equal to RL cube by 48 EA. That's it. Then you want to find R. What is R? 48 into 8 48. So 5WL by 8. That is R. So that's it. R is 5WL by 8. So that's it now. That's it. If you find out one extra equation, one extra value, then remaining 2 is easy. Understood? That's it. Enough. So I will call it as a C. It's 10 by 16. I will write it. Why it is? No problem. I will write it as a 10 by 16. Why it means C it is. If it is 5 by 88 or 10 by 16. So total amount of force is what? Total amount of vertical force is what? WL. Understood? Total is WL. So 10 by 16 is acting at center. So remaining at two supports, what is? So remaining is 6 by 16. Understood? 10 by 16 acting at center, remaining 6 by 16 at two supports. At two supports are equally distributed, so equally spacing and loading is also equally distributed throughout the span. Then what is that value? So it's 10 by 16. This is by 3 by 16. This is also 3 by 16. Are understood? 3 by 16. That's it. Enough. 3 by 16. 3 by 16. If it is called as 10 by 16. Okay. Otherwise, if you write a 5 by 8 also, you will get 3 by 16. 3 by 16. Okay. That's it. That's it. If it is loading, it is 3 by 16 WL, 10 by 16 WL, 3 by 16 WL. If you keenly observe, if you observe it, center support has taken more load. Understood? Total load is WL. Center support taken more load. Compare with the edges. Understood? That's it. That's the matter. Okay. So if it is L by 2. So and also can we write what is the bending moment at B? C. Bending moment at C. What is the bending moment? A and B are simply A and B are. See, it is A and B are hinge supports. A and R hinge supports. Moment is 0. Bending moment is 0. But C also. Sir, C also hinge, sir. So how can we get bending moment? So C is a hinge and fill out. అంతే. కానీ hinge behave as a fixed support, fixed joint. Hinge behave as a fixed joint. Understood? So C has a bending moment. C is not a hinge joint. It is a behave as a fixed joint. Fixed support kada, fixed joint. What is the difference between fixed joint and fixed support? Fixed support, there is no deflection. For fixed joint has a support. If you see it is a C joint. If it is C joint, it will rotate like something like this. See, it is theta. C is behave as a fixed joint. It will rotate, but exactly it will maintain uniformity. Otherwise, if it is C, if C is a fixed joint, he is a hinge joint. C is a hinge joint means then what? It will rotate like this. If it is a C is a hinge joint, because C is a hinge means it will allow every section, allow every member freely rotate. But C is a fixed joint, it will rotate, but it can't allow with respect to their own. It will allow with respect to the joint C. Okay, C is a fixed joint. Understand? So support is hinge support. We call it as a C is a hinge support, but it behave as a fixed joint. It will rotate. If you see, just if I will give another example, not an example, I will give a deflection diagram. If it is something, so phi is something, this is, if some load is there, how will deform? See, it will deform like this. Are understood? The slope, otherwise this. Are understood? So it will deform, maintain slope, maintain uniformity. So the load, see, load is acting only on A and B span only, but the load distribution is there in BC also. So BC beam has also bending moments. Are understood? BC beam in between any section, this section, these sections also has bending moment. That is called continuous beams. Are understood? If it is only simply supported, if it is simply supported, if you apply a load, so this is simply supported beam. So most of the bridges using this. If it is simply supported, so load is distributed only this. There is no connection. If a connection is there, the load is transferred to the another portion also. So that C center is called as a hinge support, but it behaves as a fixed joint. It will rotate, it will allow. Are understood? So it has a bending moment. Okay, are understood? So B is 0, A is 0, because those are the end joints. They will rotate it, but there is no moment because those are the end. But C has certain moment, because it will rotate means what? Some moment is applied at that location, it will rotate it. Are understood? So see it is, if you see, now we will see. We already write it. Okay, so what is the bending moment at B? So write down just at C at C, bending moment is, write down from B to this location, write down 3/6 bending moment at C, 3/16 WL into L/2. Are understood? It will go like this, and minus, this is a centroid, this is the gravitational load. So W L/2 is the total load, and it acts as a center, L/4. Are understood? L/4. What is that value? 3/32 WL square by 8. 32, 3 minus 4 minus WL square by 32. So minus WL square by 32, that means opposite direction. So sagging moment. minus WL square by 32 means sagging moment. B has a bending moment. So are understood? B has a bending moment. If you write down from this from this section also, from A to B also, you will get same thing. You will get same thing. So what is the purpose to tell this problem is to write down the free body diagrams. I will write free body diagrams. I will write free body diagrams. How it is? See. I will write free body diagrams. So this is B. Sorry. C and B. Okay. So B has C. Free body diagrams. Na? It is a B. So what is the reaction? What is the reaction? I will separate AB and BC. I will separate ABC. I will separate AC and BC. Those are the free body diagrams. Okay. So I will separate it. So B has a support reaction is what? 3 by 16. So 3 by 16. And also it has loading. Are understood? It has a loading. Loading is W per meter. And also what is the bending moment at C? Bending moment at C is WL square by 32. WL square by 32 means hogging moment. Getting negative na? So hogging moment means this direction. WL square by 32. And also to balance the load, it is a free body diagram. It is a free body diagram. Free body diagram means it itself is a static equilibrium. Free body diagram means, I will say it once again, free body diagram means it itself is a self equilibrium. So self equilibrium, okay, are understood? So C it is, and C also has support. C also has support. So what is the reaction at C? Sir, reaction at C is, so what is that? 10 by 16 WL. So 10 by 16 WL is the reaction developed to maintain that whole body. So at C, just C, at C the 10 by 16 WL reaction is developed to support whole because it is a junction. The reaction, some of the reaction is maintained CB, some of the reaction is maintained CA. Are understood? So what is the value of at C? So this is a self equilibrium. And also if you see, I will write AC. So A has a support of same thing 3 by 16 WL. If it is a loading, it is a W per meter. So okay, this is length of L by 2. And C has a bending moment of WL square by 32. Hogging moment. Hogging moment is hogging moment. Hogging, na? That is a hogging. So that is a WL square by 32. And also a reaction is there. So the total combined of these two will give 10 by 16. Not individual, because the reaction is developed to balance both sections because it is a junction. So individual. So AC, now it is AC is one free body diagram. CB is now another free body diagram. Every free body diagram is self equilibrium. And once again you want to observe it at C. See the junction C. So for the CB it will see, it will in this direction. Understood? So on BC, so on ACA and CA, which direction? This direction. Sir, both are hogging na. So how you, one is clockwise, one is clockwise. So one is clockwise, another is anti-clockwise. You write it na. Sir, both are hogging na. Both are hogging. So that is the observation. So if you see, it is for CB, it is hogging. This is the direction of hogging. For CA, this is the direction of the hogging. Are understood? And also you observe it. C is a joint. It is a one point in the total section. So every point moment is 0. Are understood? Every point, not a bending moment. Every point, every location moment is 0. That's why the joint of C is also equilibrium. That joint C is also in equilibrium. That's why C, one direction it will maintain WL square by 32. Another direction it will maintain WL square by 32. So now if you see, it is self equilibrium. Na? It's moment is what? Moment is 0. So that's why if any bending moment diagram, so I understood, if any bending moment diagram, you can come to one side or come to another side. Both will get same answer. So if you come this side, it will give some bending moment. So you come to this side, this will also give same bending moment, but both are different different direction, but if you take it is exactly that is the moment at that location. One is equilibrium, one side at equilibrium. So if you're getting from this, it will get like this. If you from this will get like this. That is the moment, but the giant is also is in equilibrium. Understood? So C is in equilibrium. So then, so compulsory at C. So you write a free body diagram. Free body diagram means the WL square by 32 is acting for this direction and this direction. Okay. But if you see only joint, it is also, if you get both two different directions. Just feeling, that is the only that is an observation. Not an observation, that is the writing of to draw a bending moment diagrams, that is the criteria. But you have to maintain aptitude or just observe it. So this is the free body diagram for a CA and CB. Understood? C is also equilibrium. C has a bending moment of WL square by 32 only. C has a bending moment of WL square by 32 and it's a hogging moment. And it's a hogging moment, not a sagging moment. Okay? So it's like, so if you see, if you observe it, what is the reaction at RC with respect to B, and it's a RC with respect to A. What is the RCB? What is RCB? What is RCB? You can just taken total vertical load. Total vertical load is what? WL by 2. And then WL by 2. This is the L by 2 distance. So is equal to the 3 by 16 WL plus RCB. So what is RCB? WL by 2 minus 3 by 6 WL. Okay. 16 8 ja minus 3. 5 by 16 WL. Are understood? 5 by 16. So same thing RCA also. So now if you just feel that this is a 5 by 16 WL. This is a 5 by 16 WL. So combined what will get? 10 by 16. So half will balance the other, half will balance the other. Half will balance CA, half will balance CB. This is the writing of free body diagrams. Every free body diagram is in a self equilibrium. If you observe it, C has a bending moment of WL square by 32 is a hogging. So if you observe it, we provide hogging moment of for CB, hogging moment of CA also. But if you see the joint of C has a bending moment of WL square by 32 hogging. But if you write down, so representation, that is a good word I think. Representation. So that will show like this. Okay. So if you write it, if you write it a shear force diagram, just write a shear force diagram. Shear force diagram. It is very easy. See it is. So at B is what? At B is, see it is. At B is 3 by 16. 3 by 16. 3 by 16. Later on it will go up to C. See WL by 2 will come. WL by 2 will come na? WL by 2 come. So 3 by 16 in this direction. So okay. You may confuse it. So you have an idea of to write on downside. Okay. 3 by 16 WL. So later this gravitational load will come downwards. So it will decrease. It will decrease up to 5 by 16. Up to 16 5 by 16. So it will come to like at the C. See it is come to decrease at 5 by 16. So that's it. Are understood? This is a 5 by 16 WL. That's it. That's it. You can write it. Uniformly varying distributed load. Na? So exactly C has 5 by 16. Sir, C has not a 5 by 16, sir. In reality, C has a 10 by 16, sir. That will come to the point. So if you see it is free body diagram, it's a 3 by 16, it will come 5 by 16. But reality C has a 10 by 16. So if you see, just club it. If you, now you can write it the shear force diagram for AC. Now write. Now once again write it. So again see it is C. So at RCA, what is that value? 5 by 16. So 5 by 16 bottom. 5 by 16 bottom. 5 by 16 bottom again. So again it will come to decrease and up to 3 by 16. So this is again 5 by 16. Or observe it. If you try and write down the free body diagrams, it will be easy to draw. Now if you see C has shear force of 10 by 16. It's a 5 by 16. It's a 5 by 16. It's a 10 by 16. At that location C has a shear force of 10. C has there? Is there? Yes, it's there. If you write down the free body diagrams, it will give the easy way. And also if you write down the shear force, otherwise if you don't know the free body diagrams, if you draw a shear force diagram, if you draw a direct shear force diagram for this, you will observe free body diagrams. Just cut it. You can observe a free body diagram. So then you can easily write down the free body diagram. Based on the shear force diagram, you can write down free body diagrams. Are understood? So without knowing the free body diagrams, directly you can draw shear force diagram for this section. Later you can observe it shear force for the AC section and CB section. Or observe it. That's it. That is the free body diagrams. And also if you draw bending moment diagram, so bending moment diagram also. Okay, so bending moment diagram also. See it is, so at 3 by 16, so 3 by 16 into something multiplication goes to this direction and it will goes to dot, so automatically it will decrease. So at C, so it will decrease. What is that value? So WL square by 32. Are understood? WL square by 32. So again C has a WL square by 32 hogging moment, and A has, it will come to this direction. Are understood? It's a hogging moment, na? It's a hogging moment. Negative. This is a positive. This is positive. You will get C. If you see, at C has only one bending moment, not a two bending moment. It is a hogging moment. But how can you draw a free body diagram? Says look like this. This is the way to draw representative hogging moment for, it's a hogging moment for CA and CB also. But if you draw, if you observe it, one is clockwise, one is another clockwise. That means C is also in equilibrium. That WL square by 32 is for CB it is a clockwise, CB is a anti-clockwise, CA is a clockwise. C is also in equilibrium. If you write down the free body diagram of giant C, that is look like this. WL square by 32, WL square by 32 is 0. Moment is 0. Every section has moment is 0. Every location moment is 0, not a bending moment. Once 1000 times I said it, moment is 0 everywhere, not a bending moment. Okay, so that is just write in. Otherwise you can write like this also. What we write in a fixed beams. See it is AB. So see it is AB has uniformly distributed load. AB has uniformly distributed load. BC also has uniformly distributed load. So you can take it as a AB and BC also two fixed beams. Just see, two simply supported beams. Taken two simply supported beams. Otherwise, taken two simply supported beams. That's it. Two simply supported beam. It will come. What is that value? WL square by 8. So not L, it's L by 2 na. WL square by 2 is 4, 32. 32 na. WL by 2. It's not L na. It's a distance of L by 2 na. It's a distance of L by 2. L square 2 4 is 4 8 32. WL square by 32. These are the only free ends. If you feel it is a AB is a free end, BC is also free. But giant C is a fixed giant na. Giant C is a fixed giant, not a fixed giant, it's a fixed giant. C is a fixed giant, B is a fixed giant. C has a fixed end moment of WL square by 32. C has a fixed moment of, C has a hogging moment of WL square by 32. We already done na. In a fixed beam we write it na. So in a fixed beam analysis we just write it. So otherwise I will show you. So okay, no problem. I will show you. C has a fixed beam. C has a fixed giant. It has a fixed end moment of WL square by 32. A has a fixed end moment of 0. B has a fixed end moment of 0. See this. I will write A, B, C. Three fixed. What we write in somewhere in first chapter or second chapter. Okay, we write it now. So we assume it is a and B are free ends. బ్రేక్ అవుతుందా? మనం ఏం చేయలేం. ఓకే, స్లోగా చెప్తానులేండి. వాయిస్ బ్రేకే కదా అవుతుంది, వినిపిస్తుంది కదా. వర్షం ఆగిపోయింది, ప్రాబ్లం లేదు. రెయిన్ ఆగిపోయింది, ప్రాబ్లం లేదు. See, A and B as we taken as a free ends. We write down the free bending moment, free ends taken as a free ends, and later we draw bending moment diagram, and later A and B taken as a fixed ends, and fixed end moments we draw. One is positive, one is negative. We just drawn a shear force bending moment diagram like this. Both are equal. You know it. These both are equal. You know it. Just representation is small changes. Okay. So like this. Today also same thing. So this is okay, you can write it. Otherwise, taken a B, AB is a something, so AC is something free ends, BC is a CB is also taken free ends. And if you now taken everything is a fixed giant, everything is a fixed giant. A has a fixed end moment of 0 because hinge giant. BC is a, so B is also 0 moment, but C has a WL square by 32 is a hogging moment. So now you can add fixed end moments. You can add fixed end moments. So that is, this is a negative, 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 negative. So previous it is, previous is hogging moment, positive, 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 positive. So negative positive will cancel. So what is the cancel? So the cancel is, this is a cancel. Are understood? This will cancel, this will cancel. Remaining is the moment. So just observe it. Just observe it. That's the same meaning. So exactly at this location is 0. At this location, this is the moment. See, this is the moment. Both are equal. So see, just cut it. Some negative moment is cut it. Some positive moments or negative moment. Both are will, some portion is clubbed together, that is removed. Remaining portion is the only negative moment. See, it is, both are similar. Both are similar. The bending moment at this location is this value and this value. Both are equal. If you represent this, okay. If you represent like this, this is also okay. This has some calculations required. So this is just, we represent it. Whatever, where, which location you require, just take it. But in reality, if you see, in reality, we required where the location, what location, what is the maximum bending moment. We required only maximum bending moment. We required only maximum bending moments. So that's why directly represented by like this, it is easier. You know, directly this is a maximum bending moment, WL square by 32. Because this is also WL square by 32. We already know this is also WL square by 32. So the remaining portion is not, is compulsory less than WL square by 32. This is the location of bending moment. This is the bending moment. These are all equal, these values. Are understood? We didn't calculate those values, but representation is same. You can write as a, you can take as everything as a hinge giant. You draw bending moment diagrams. Those are the hogging moments. And later we can assume everything is a fixed giant. What is the fixed end moments? There is no loading. We can't take any loading. Just take in fixed end moments. We just take in fixed end moments are hogging moments. We write it as a negative moments. Positive negative cancel. We can write, represent like this. Okay. Otherwise you calculated every section, every junction, you can write it. Okay. That's the story. That's I want to tell you, like, this is also one fixed end. This is also one of the continuous beam. But you can solve it as a only one extra equation is required. Na? That's why we solve in some other method. Okay. So I will show this problem same in next method. So what is that method? So what is that method to solve the continuous beam is, that is called 3 movement methods. That is called 3 movement method. And also it is called as a Clapeyron theorem. Clapeyron theorem. Everything is same up. This is called force method. This is a force method, not a displacement method. Okay. How it is? What is it? If you see, if you taken any continuous beam, so something, I will assume like this. Otherwise, if you taken something, where it is, otherwise something anything, any continuous beam, okay, any continuous beam. So some arbitrary loading is there, arbitrary loading, some it has arbitrary loading is there, okay, some arbitrary loading is there. See, it is MA, MB and MC moments. If you find out the moments, later you can easily calculate the reactions. The indeterminacy we taken as a moments. The indeterminacy we taken as those are the moments. If you find out the moments, then find out the reaction is taken directly by the equilibrium equations. Fy equals 0 and moment is 0. To take anything, you can calculate it. So I want to find out these moments MA and MC and MB. So, understood? If you find out the MA and MC and MB moment, not reaction, then you can easily find out the reactions. Later you can use those equilibrium equations. Understood? So first you have to find out the moments, fixed end moments, and also fixed giant moment. So C is called as a fixed giant. It behaves as a fixed giant. Okay. So what is that? So see, it is no required of proof. So no required of proof has no significance of any proof. No significance of any proof. See, it is MA into L1. So if you taken this is a L1. This is taken as L2. This is taken as L2. So compulsory you choose two spans. Compulsory two spans are required. Two spans are required. MA plus L1. See, it is MB plus L1 plus L2. So otherwise, okay, I will write it. So continuous na. So this is MA, this is MB. I will call it as this is MC. Continuous B C D, A B C D, continuous. Okay. So MA plus L1 plus MB plus L1 plus L2 for this so 2 MB, because MB at center na, it balances AB and it balances BC. So it has a 2 plus MC L2. MCL2, these are the fixed end moments. MC, MB, MA are fixed end moments, is equal to the 6A1 X1 divided by L1 dash 6A2 X2 divided by L2. Sir, what is A1 L2 X1? So that is I want to explain. So what is A1, what is A2? So A1, A2 are the areas of bending moment diagrams of spans AB and BC if support B taken as a simply supported. So if you observe it, just taken as a B as a simply supported. B as a simply supported means what? It will come, it is a B C. Yeah, na? So AB has what loading? AB has loading of point load. So point load bending moment will come this, taken as a free. Okay. So BC has uniformly distributed load. It will come, that's, these are the area based on the loading. So the areas of the bending moment diagrams A1 and A2 are the areas of the bending moment diagrams of span AB and BC if the support B as a taken as a simply support. So you can easily calculate it, because it is taken as a simply supported. We can write down the bending moment diagram, very simple. And what is X1, X2? X1 is the centroidal distance for bending moment diagram. Centroidal distance for bending moment diagram for span AB from A. So if you taken it is AB na. So what is the centroidal distance? Where is the centroid? Based on the load it is there. Where is the centroid? Maybe somewhere from A This is x1. So that is x1. So x2 is same centroidal distance for bending moment diagram for span BC from C, not B. So for BC, central distances come from, this is x2. This is x2. Are understood? That is x2. That's it. That's it. So this is the equation, we can get it. And also some of the textbooks like some of the textbooks has something like this. So it will write down like this. This is a plus equal to 0. They write it. I write like this. I chosen like this. No, I chosen like this is equal to. What is the difference, sir? So like one positive sign is different, na? One positive, one negative sign is different. So now if you choose like this equation, you will get MA, MB and MC is in positive values, positive or negative. If you come it as a positive, it is a hogging moment. I taken as a hogging moment. Otherwise, if you get a negative value, you will get that is a sagging moment. Sir, why, sir? I am very much interested to take a hogging as a positive, hogging as a negative sign. If you want hogging as a positive negative sign, so taken. So I will, okay, for your convenience, I will do the problems as your wish. So I will choose same sign. I will use same sign. So that's why I will write, okay. I will choose, okay. I will go to this, okay. So I will go to your zone. So this is the equation. So now for your convenience, negative is hogging, positive is sagging. Okay. Because some textbooks may taken as a so 6a by that is come to out of the is equal to. So at that situation, MA and MBC, if you get a positive value, that is a hogging moment. So negative moment is sagging. But okay, we fixed negative is a hogging. So I will choose this. This is the equation. No problem. Anyway, so sir, okay, this is the equation. No need of proof because it has some calculations, but no one need a proof. Okay. So how we will solve problem? How we will solve a problem? So this is the equation. So if you see MA and MB, MCs are three unknown is there, but equation is only one. Equation is only one. One is the equations are three unknowns are there. How can we solve? How can we solve means if you see MC, if it is taken, these two spans are one time. So later again next two spans are again next equation. So if you taken these type, so MC and MC will come two times or three times. You will get easily, but I will show in problem. Okay, I will show in the problem. So I will solve one problem. That is what we already solved. This problem, na? So we already solved this. We again solved this problem. So this is the Capricorn theorem. No need of proof. I once again said that no need of proof. Otherwise, if you want, search is the proof. No need of proof. Okay. See, it is taken the same problem. If any proof is required, I will explain. So this proof is not required. Okay, understood? I said so many proofs. I am more interested in proof than remembering the formula. In that situation also I said that the proof is not required. So that means you understand. Okay. So same problem. Understood? Same problem. How can we solve it? So this is L by 2. This is L by 2. So indeterminacy of 1, but okay, taken as a continuous peak. We will solve it. So what is that means? MA L1 2MB L1 plus L2 MC L2 is equal to the 6A1 X1 divided by L1 6A2 X2 divided by L2. So very easy formula. So required. So see it is. See it is. Okay. Taken as a free ends, taken as a simply supported beams, taken as a simply supported beams, taken as a simply supported. So what is the bending moment diagram? Bending moment diagram is this. This bending moment diagram is this. Antana? Exactly. Okay. So same. What is the bending moment? What is the bending moment at? W L square by 8. So but it is L by 2 na. W L square by 32. L by 2 taken as a L is L by 2. W L square by 32. W L square by 32. This is a W L square by 32. Okay. So what is the centroidal distance? Centroid is exactly this is a parabolic. So you can easily conclude that this centroid is come from A. This is A. This is B. This is B. C. So centroid is exactly L by 4. So this is also centroid from C. This is also L by 4. Are understood? So from C it is x1 is centroidal distance from A. If you choose two spans A, this is B, C. Centroidal distance x1 is from one thing is from A and one thing is from C, not B. So okay, B is at center. Just feel it is a B is a center. So that's why one choose from A, one choose from C. Okay. So now for apply a formula. Apply some formula. Same formula. See it is. So you know already what is MA is 0. Sir, how can? So A is a simply supported na. A is a hinge joint. Hinge support. A is a hinge support. And MC is also 0. C also hinge support. Not a fixed support na. But B is a hinge support, but acts as a fixed joint. Act as a fixed joint. I once again said it has a bending moment. B has a bending moment. A and C are end locations, though has no bending moments. No bending moments. Okay. So MA is 0, MC is 0. Only MB is required. MB is required. So just use that equation. So MA L1 2MB L1 plus L2 MC L2 is equal to 6. So I write it directly. MA is 0, MC is 0, and L1 L2, this is L by 2, this is L by 2. L1 L2 is what? L by 2 na? So that's it. 6. Area is what? Area is at first 6 area A1. This is regarding to the first span, this regarding to the second span. Same thing, this regarding to the first span, this regarding to the second span. So this is a center at C. This is regarding to the center point. So that's why you have to remember. Okay. So if you see 6 area is what? 2/3 of WL square by 32 multiply with L by 2. That is an area. And what is the central distance? Central distance is L by 4 divided by L by 2. What is L1? L1 is L by 2. L2 is also L by 2. So that is 1. But again, if you take in second 6a to x2, that is also same, equal na? That is also equal. So that's why I multiply with 2. That is also equal. So observe it. 2MBL is equal to the 2MBL is equal to the 6 2 by 3 WL power 4 32 2 4 into 2 by L. That's it na? That's it. That's it. Cancelled it. 2 2s are 4 cancel. This 2 cancel. So what is 6 by 32? 6 by 32 into 3. 6 by 32 into 3. So WL cube 2MBL. Okay, 2MBL. Okay, so see it is L cancel. It is L square. What is MB? 6 by 32 3 2. 3 is 1 by 2. WL square by 32. That's it. You got it. You got it. Are understood? You got it. This is also one method. WL square by 32. Once you got the MB value, So to find out the reactions, C value, A value, that is also easy because it has only one indeterminacy. Are understood? It has also only one indeterminacy. So otherwise, sir, so otherwise, if it is something like this, so otherwise, if you see it is, so otherwise if it is there like this, otherwise it is there something A, B, C, D. So L, not L by 2. Okay, otherwise taken L by 3. L by 3. So see it is A and D has 0 moments. Bending moments is 0. But B, C has moments. So okay, B and C has a moments. Are understood? So how can you find out the B, C moments? Indirectly you can't solve it because see it is indirectly you can't solve because exactly 1, 2, 3, 4 external reactions are there. You have only 2 equations. 2 is the external indeterminacy excluding horizontal. How can you find out those 2? You can't solve it. Just taken, you can't solve it. So but in a Capricorn's theorem you can solve it. How can you solve it? Same method. How can you solve it? Just see it. Just see it is A, B, C taken one time. Just take one time. So you will get equation MA, MB, MC in terms of something. MA cancel. MA is 0. You know it. So A, B, C taken A, B, C one time equation. You will form one time equation. Taken A, B, C is the span. So A is 0. You know it. Write down the equation. Write down the equation. Equation will come in terms of MB and MC. Those are the unknowns. But next time you choose B, C, D. Next time you choose B, C, D. So okay, B, C, D. Next time you choose B, C, D. Then you will come MB, MC, MD. But MD is 0. You know it. It will come in terms 6A by you will easily get because those are the simply supported. You can get area of this bending moment diagram and the central distance. If you see it is B, C is 2 unknowns. For the only one equation, if you taken only one equation, 2 unknowns you can't solve. But you again taken B, C, D is and again another 2 spans. You choose those and again 2 spans. You write down the Capricorn's theorem. You will get another equation in terms of B and C. If now 2 equations, 2 unknowns. You can solve it and you will get MB and MC. That's the meaning. That's the meaning. That's the one I want said. So if so many number of joints are there, number of supports are there. So continuous beam, it is a continuous beam. So many supports are there. How can we solve MB, MC, MD? So we have only one equation, sir. How can we solve? That is your common doubt. Choose spans and we form equations. How many number of unknowns are there and how many number of equations we required. So that how many number of equations are required, choose that. Based on that you write down the equations. You write down the equations and solve it. You will get MB and MC. Are understood? So that is your assignment. This is your assignment. Do it. Okay. This is your assignment. So okay, what is MB and what is MC, and also support reactions. I am more interested in support reactions. How the central supports are taken. How much percentage of loading? See previous loading condition. The previous loading condition. See it is previous loading conditions. Almost 80%. Na? So total is 16. 10 in 16 out of 10. So almost 70%. 70% taken as central loading only. So remaining 30% taken as outsiders. Remaining 30% loading is taken by outside supports. So I am more interested in this point problem also. How much loading taken by the central supports? How much is excluded for the extreme supports? That is my interest. Just do it. Okay, just do it. Otherwise, we will solve the problems tomorrow. Okay, otherwise we will solve the problems tomorrow. So next 2-3 classes we will solve this problem. This is the method, no need of any proof regarding for this Capricorn's theorem, because it's very basic, okay, but no need of proof. Okay, so this is the equation. Based on this equation we will solve so many different loading conditions, different support conditions. We will solve the problems next 2-3 classes. Okay, that is the end of the second unit. Next to 2 or 3 classes required, we will solve more problems. We will solve more problems regarding the same equation only, no need of fear. We will solve next 2-3 classes using the same equation. That's the end of the second unit. Okay, that's it. If you have any doubts, ask me, otherwise leave it. Already main leave అయిపోయాం సార్.